Welcome to LIB Academy. In this video, I am going to take you through how to evaluate problems using these standard integrals. They are normally used to solve Gaussian integrals, which are very important aspects in quantum chemistry, physics, and then statistics. So in integrals of these forms are referred to as Gaussian integrals. Let's start solving practical problems. We are going to use the standard integrals to evaluate the following. And looking at all of these integrals, they are of this form. So we are going to use this to evaluate them. Number one, we have integral, which is here, from negative infinity to positive infinity, e to the power minus 2a x squared. That it should be of the form square root of pi over a. In this case, square root of pi over a. What is our a? Looking at where our a is the coefficient of the independent variable, the variable that we are varying, which is x squared here. So generally, a is the coefficient of x squared here. So the coefficient of x squared here is 2a. We are not going to take the negative sign into consideration. So here 2a. So that is it for I. And for I, we have minus 2b x squared. So to evaluate that, just have to take square root of pi over the coefficient of x squared here, which is 2b. And the same thing to do for I. You have to take square root of pi, and then our a here is a coefficient of the independent variable square. So coefficient is 4a. So here giving us 4a. And looking at IV, just have to take square root of pi all over a, and a is a coefficient of x squared, which is b. So that is how you can apply this standard integral to problems like this. I mean, basically, these are the short way of solving Gaussian integrals of this form. Evaluate integral from negative infinity to positive infinity x squared e to the power negative a x squared. So looking at this integral is of this form. Generally, in an examination or the standard integrals will be provided to you, and what you have to do is to just know how to apply them. So this is equal to square root of pi over a, and a is the coefficient of x squared here, and here too we have a. So square root of pi over a, our a here is just a, coefficient of x squared is just a. We are not taking the negative sign into consideration. Then after that, we bring in, this is multiplying odd numbers up to 2n minus 1 over 2a all to the power n. So what we have to do now is to focus on this and evaluate it. So 2n minus 1, what is our n here? N is from 1, 2 to 3. I mean, n is basically not decimal numbers, the value of n. If you want to solve for n, we can just say equate this to 2n. So 2n equal 2. But if you are comparing, just equate this, the power of x here to this, to solve for n. So our n equal 1. So if n is equal 1, this whole term here becomes 2 multiplied by 1 is the same as 2 minus 1 giving us 1 all over 2a. A here is a coefficient of x squared, and it is still a. So we just 2a, then 2a to the power n, and our n is 1. So you can just leave it as it is. So after that, we take it from here. The value of n here 2n minus 1 is what is going to detect the odd numbers that we have to multiply here. So this is going to give us square root of pi over a multiplied by 1, over 2a. If let's say the value of 2n minus 1 here gives us 5, then we have to multiply square root of pi over a by 1 by 3 by 5 then over 2a. So the value of 2n minus 1 here will indicate the odd numbers that we should multiply right here. If it is 7, if after evaluating this we get 7, then we have to multiply odd numbers from 1 to between 1 to 7, or from 1 up to 7. So we're going to be 1, 3, 5, 7. Let's take another example. So simplifying this is the answer for this problem. You can go ahead and write it as 1 over 2a square root of pi over a. So let's evaluate this. So first of all, we are going to compare this power to that. So we know that 2 multiplied by 2 is what is going to give us 4 here. Then our n here equal 2. Or we can just equate this here, 2n here, to the problem that we want to solve, the power of x here, equal the power of x's. So this is going to give us n equal 2. Now we know our n. We know that this whole term here, this e to the power minus a x squared here is going to give us square root of pi over the coefficient of x squared. In here it is a. So a. We are going to bring everything here. So all numbers up to 2n minus 1 over 2a to the power n. So now let's evaluate this whole term here. Let's take 2n minus 1. Let's evaluate 2n minus 1 over 2a to the power n. Our n equal 2. Our n equal 2. So 2 multiplied by 2 minus 1, that is going to give us 2 by 2 is going to give us 4. Minus 1 is going to give us 3. So 3 all over 2 multiplied by e. And a is the coefficient of e, x squared from e. So which is a. So just leave it as a. Then our n here is 2. So we just have to put here 2 here. Then let's simplify it. 2 to the power 2 gives us 4. And then a to the power 2 gives us a squared. So since here the numerator here is 3, we are going to multiply this term here by odd numbers up to 3. So this term here becomes square root of pi over a. So multiplied by 1 multiplied by 3. So those are the odd numbers that can be there. Divided by 4a squared. So 4a squared. So this is going to give us 1 by 3 is the same as 3. So square root of pi all over a multiplying 3 over 4a squared. Can just simplify it as 3 over 4a squared square root of pi over a. So how do we simplify this? Using the standard integrals. So first of all, we know what this term is going to give us. It's going to give us square root of pi over the coefficient of x squared here, which is 2a. So we're going to get 2a here. Then odd numbers up to 2n minus 1, right, over 2a to the power n. So to solve for n, just equate the both powers, or you can just it. You know that 4 by 2 is going to give us 4 by 2 is going to give us n. So which means 2 by 4, 4 by 2 or 2 by 4 is the same. It's going to give us n. So our n equal 4. But also you can equate the powers of x. So 2n here equal 8. These standards will be provided to you in the exams hall. Mostly they are provided. So our n equal 4. Mostly they will be provided. So now that we know our n, let's evaluate 2n minus 1. So 2n minus 1 gives us, let's say, 2n will give us our n is 4 by 4 minus 1 all over 2a What is our a? Our a is the coefficient of x squared. Here it is 2a. So 2a. A is always the coefficient of x squared, and the coefficient of x squared is 2a. So 2a all to the power n, and our n is what? 4. So 2 by 4 gives us 8 minus 1 gives us 7. So 7 all divided by 2 by 2 gives us 4a, then 4 to the power 4, 4 to the power 4, and then a to the power 4, 4 to the power 4, a to the power 4. That's what we get here. So since this term here, the 2n minus 1 term gives us 7, we are going to multiply all numbers up to 7. So this term here becomes square root of pi over 2a, multiplied by 1, multiplied by 3, multiplied by 5, multiplied by 7, then all divided by our 2a to the power n, which is 4 to the power 4, a to the power 4. So 4 to the power 4, a to the power 4. Multiplying these terms here gives us 105. So square root of pi over 2a multiplied by 105 all over 4 to the power 4, a to the power 4. So let's simplify further. 4 to the power 4 is going to give us 256. So let's write it this way: 105 all over 256, a to the power 4, a to the power 4, square root of pi over 2a. So that is how you can use the standard integral to evaluate Gaussian problems. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.